Okay, let's talk about linear inequations. So, up until this point, we've been talking about equations, linear equations, where the left-hand side is equal to the right-hand side. But what if that's not the case? What if we have something like this, an inequation? X is less than 2. Well, what are we talking about here, and how do we work with these? Well, first place to start is to look at what are the signs that we use when we're talking about inequalities. There's 4 different ones that we use. Greater than or equal to, less than or equal to. All right, so let's have a quick look at a couple of them because there's some important distinctions. Okay, so here we have an example of 2 inequalities. We've got x is greater than -1, and we have x which is greater than or equal to -1. And this works the same way for the less than and equal to as well, what I'm about to tell you. Okay, so if we were to actually graph these 2 inequalities onto a number line, well, what would they look like and how would we make them look different? Because they're very similar. Here we've just got x is greater than -1, and here we've got x is greater than or equal to -1. So the difference is that this second inequality actually has -1 as part of what fits, part of the solution for that. Whereas this top one, -1 doesn't count. So do we just draw a line representing above -1? Well, that seems a bit messy because where do you start that? So here's what we do. If we are looking at this second one, greater than or equal to -1, or if we're looking at less than or equal to, you represent the place where you are starting to show your answer, for in this instance it's -1, as a closed circle. Can you see that? How it's a solid dot. All right. Whereas the just greater than, when we represent that, we are representing that with an open circle, an open dot. Okay. So when you see things drawn just like this, then you can tell pretty easily this one doesn't include -1, but this one does. It's inclusive. Okay, so now that we've sort of talked about these linear equalities and what they are, let's talk about how we can solve these things. Okay, so solving linear inequations. So I've got one up on the screen there. X plus 3 is less than or equal to 4. Okay, well, I can say to myself, well, I can take 3 from both sides, and I'll have x is less than or equal to 1. Okay, so when I go to actually graph that, I know it has to be a solid closed circle. But where do I start it? Well, I have to start it right here where x is less than or equal to 1. So I'll shift my graph to that point there, and that's exactly where and how you would draw that one in. Let's have a look at another one. That was a really easy one. What about this one? 6x minus 7 is greater than 3x plus 5. Well, okay, now I've got unknowns on both sides. I have to do a little bit more thinking. I want to shift one of the unknowns, so I'm going to shift that 3x. I'm going to take 3x from both sides. I'll get 3x minus 7 is greater than 5. Now I ask myself that question I ask all the time, is my unknown by itself? No. What's happening to it? Well, it's being multiplied by 3, and then I'm adding or taking away 7. So to get rid of that take away 7, to work backwards, we have to add 7 to both sides. Very good. And we get 3x is less than or greater than 12. Okay, so I ask myself that same question. Is my unknown by itself? No, it's not. What's happening to it? Well, it's being multiplied by 3. What's the reciprocal function of multiply by 3? It's divide by 3. So I'll divide both sides by 3. I'm going to end up with my x being a value of greater than 4. So when I draw it, there's my number line. It'll be an open circle, and then the line with an arrow on the end representing all the values off to infinity of x being greater than 4. Okay, so easy, I hear you say. There's one caveat, one special rule or case that we need to be a little bit careful of. Let me show you what that case is. Take this one here. 6 is greater than 5. Well, that's very easy. That's for sure. Okay, but what if I multiply both sides by -1? Well, if I multiply both sides by 6 times -1 will be -6. 5 times -1 will be -5. However, there's a problem with this one. That is not correct. -6 is not greater than -5. In reality, -6 is actually smaller than -5. So the really important thing to remember that when we're multiplying by a negative number or dividing, for that instance, by a negative number, we have to change the direction of the inequality sign, otherwise it doesn't work. Okay, so don't forget that you have to change this direction. This has to change. Otherwise, you're not going to get that correct.